Hi everyone, this is Raj. I'm going to solve the previous question of GATE data science and artificial intelligence, and the question from the statistics background. So basically, I am solving the questions. I am giving also at the same time I am giving you some theory which are relevant to the question and also which is helpful for your future. So this is the question number 11 from the paper 2024. So this is asking about the first option is the mean and the variance of the Poisson random variable is equal. First of all, I want to tell you about little bit about the Poisson distribution. So first of all, uh, in statistic, there are two types of random variable. The one is the discrete random variable, and the second is continuous random variable. So in discrete random variable, there is a one random variable which is called a Poisson. So let if x follows a Poisson with a lambda parameter, then the CDF of f of x is equal to e to the power minus lambda to the power x upon x factorial, where x takes the value from 0 1 2 up to infinite, and the expectation of x is equal to lambda and the variance of x is equal to lambda, and the moment generating function which is called e to the power lambda e to the power t minus 1. Now, so the first option is the mean and the variance of the Poisson distribution is Poisson random variable equal. So this is correct. So this is correct. From here you can see that. And for the standard normal variable, the mean is 0 and the variance is 1. So again, the standard normal variate is the special case of normal distribution. So if x follows a normal distribution with mean mu and sigma square with variance, then x minus mu upon standard deviation is follow standard normal with mean 0 and variance 1. So we can call this quantity as a z. So z follows normal with 0 mean and variance 1. So if z is a standard normal variable, then its mean is 0 and the variance is 1. So the option 2 is also correct. So for this question, the A is true. Also, now this is question number 12. So question number 12 is asking about there are three fair coins are tossed independently, and T is the event that two or more tosses results in head, and S is the event that two or more tosses results in tail. Then what is the probability of event T intersection S? So let's first of all we have to write the event T. Then T is the event that two or more tosses results in head. So two or more, like first of all two, so head T, head tail head, and tail head, and head. Then the event S is equal to two or more results in tail, so two tail, head tail, and then three tail. So you have there is no common in T and S, so the set for T intersection S is equal to 5. So the probability of T intersection S is equal to 0. So option A is correct. Now for this question number 18, this is the we can call match the following type of question. So first of all, I want to tell you about a little bit of these things. So first is principal component analysis. We can say that PCA, and it is used for the dimension reduction or dimensionally reduction. So this is used for dimension reduction technique. So So basically, if you have a multiple variables in any model, like, and some of the variables are irrelevant in the sense they are means some of x are already covered by some another variable, so that variable is irrelevant, so we can throw out or we can drop that variables by the help of this principal component analysis. And in this principal component analysis, we are using the eigenvalue and the eigenvector concept. So this is used for dimension reduction technique. And the naive Bayes classification is used for the generative model. Okay, and this logistic regression is for the if suppose you have a y and there is a some variable x which is independent, this is independent variable and y is the dependent variable. So whenever you have a y and it takes the value binary, means 0 or 1, then you can say that this model is a logistic regression. Okay, so logistic regression. So this logistic regression is a discriminative model. Why discriminated? Either you got a 1 or you got a 0, so this model is a discriminative. So for p, option p is a second, so p second in this, so b or c. Then we can go over the naive Bayes classification, which is a generative model, so q for 2. No, principal component analysis this, and logistic is discriminative model. So yes, so p for 2 and q for 1, and logistic regression is a generative model. Okay, let me check. Okay, so q for 3, yes, q for 3. Okay, this is some, so q for 3, so this is option C is correct one. Okay, now we have another question, which is a 24 question. The question number is 24. You can see, you have seen that which of the following, so there is a we have some 5 random variables and they are jointly distributed. So this is the condition where you have seen that these things are written in intersection format. So you have to tell about what are the condition with this formula is satisfying. So we are saying that u and v are conditionally independent of w, because if probability of u given u probability of u intersection of v given w, then we can say that this is the conditionally independent of w, and we can write this as a probability of u into probability of v. So this is the option C is correct one. Okay, now this is the question number. Now I don't know the exact solution for this, but the option is 6. I'll let you know in the next video. Okay, now we have to move to this question. So let x be a random variable which is uniformly distributed in the interval, and y is the another random variable. First I have to tell about the uniform random variables. So uniform random variable is a continuous type random variable. So if we have a x and which follows the uniform sum a comma b, then the fx of x means its pdf is 1 upon b minus a, and the expectation of x is equal to b plus a by 2, and the variance of x is equal to b minus a whole square by 12, and the moment generating function is e to the power tb minus e to the power ta by tb minus a. By the way, you can find the moment generating function for any distribution by the expectation of e to the power tx, which is equal to integration over the range if it is continuous, e to the power t of x, f of x, and dx. Okay, so for this question, from this you have seen the range of x belongs from 3 to 1 to 3, and the y belongs from 2 to 4, but the condition is the y should be less than x. Okay, so we have to find the probability. So for finding the probability, we so we have to find the probability of x is greater than or equal to y. So the condition from this, so y should be less than x, so it is from 2 to 3, and x from y to 3, and your f of x and f of y, dx and dy. You can also find the joint distribution of f of x and fy, because these are random and these are independent, so f of xy is equal to f of x into f of y. So from here, f of x is equal to 1 upon 3 minus 1, which is equal to 1 by 2, and similarly f of y is equal to 1 upon 4 minus 2, which is 1 upon 2. So we have to put in this equation. So 2 to 3 and y to 3, 1 by 2 into 1 by 2, and dx and dy. Okay, so this is 2 to 3, and 1 by 4 we can keep it out, and this, the integration with respect to this is x, and from y to 3 and dy. So this is 1 by 4, 2 to 3, and 3 minus y and dy. Then you can solve it again. 1 by 4, so this is 3y, 2 to 3 minus y square by 2, and 2 to 3. When you solve this, the whole thing, so 1 by 4, so this is 3, and 3 minus 2 minus 1 by 2, 9 minus 4, so which is equal to 1 by 4. This is 3 minus and 5 by 2, so which is equal to 1 by 4 into 1 by 2, which is equal to 1 by 8, and which is equal to 0.125. So the answer is, this is 56, so answer is 0.125, 0.125, the correct answer. Okay, now moving to this question number 57. So again, this x is a exponentially distributed random variable. So exponential distribution is again a continuous distribution or continuous random variable. You can say distribution or random variable. So if x follow a exponential with this lambda parameter, so the PDF is f of x is equal to lambda e to the power minus lambda x. Okay, and the expectation of x is equal to just 1 upon the reciprocal, so 1 upon reciprocal of this rate, and the variance of x is equal to 1 upon the square of this. Okay, and moment generating function is this lambda upon lambda minus t, or you can say that key 1 minus t by lambda to the power minus 1. Okay, or you can find the e to the power tx from that. Okay, so or you can if f of x is equal to this, then e to the power tx f of x dx mean the moment generating function is different, and when you have a 1 upon lambda times, then the moment generating function is different. So you have to check what means you have to check the moment generating function according to your PDF. Okay, I'm not writing the moment generating function. Okay, so the question is asking about 5 time expectation of x is equal to variance of x. Okay, so this we have seen that the expectation of x is just the 1 upon lambda, so 5 times 1 by lambda is equal to 1 by lambda square, so lambda cancel, and 5 is equal to 1 by lambda, and so from here lambda is equal to 1 by 5, which is equal to 0.2. so answer is 0.2. Again, this is the question. This is 8 question. Okay, so the given that the probability of t complement is 0.6, so which implies probability of t is equal to 0.4. Okay, probability of s given t is equal to 0.3, which means that probability of s intersection t given by probability of t is equal to 0.3. So from here probability of s intersection t is equal to 0.4 and probability of t is equal to this is 0.3 into 0.4, so which is 0.12. Similarly, probability of s intersection t complement given probability of t complement is equal to probability of s given t complement, which is this one. So probability of s intersection t complement is equal to this is 0.6, so 0.6 into probability of t complement, which is 0.6 again, so probability of s intersection t, which is 0.36. Now we can write the probability of s is equal to probability of s intersection t plus probability of s intersection t complement by the total probability law. So this is 0.12 and plus 0.36, which is 0.48. Now we have to calculate probability of t intersection s. We have to compute the probability of t given s, which is equal to probability of t intersection s upon probability of s. Okay, so we have seen that the probability of t intersection s is 0.12 and this is 0.48, so this is 1 by 4 and this is 0.25. okay, so answer is 58. Now this is question number 59, and again this is asking about the expectation of y given x. Okay, so first for this you have to find the f of y given x, which is equal to f of xy upon f of x. Okay, so this is f of xy is given and we have to find this f of x. So I am telling about the rule. If you have a joint distribution f of xy and if you want to find f of x, then you have to integrate with respect to the limit y, f of xy, f of x, y and dy. Okay, and then you can find the f of x, and if you want to find f of y, then you have to integrate with respect to x and f of xy and dx. Okay, now we have to find here f of x, so we can integrate with respect to the y. So f of xy is 2xy and this is dy, and the limit of y is 0 to x. So this is 2x is outside and y square by 2, so this is y square by 2. So if I put a x, so x is square by 2, so this is 2 and 2 cancel, this is x cube, and now this is f of x. Okay, so okay, dy 0 to x, and okay, y square by 2 and 2 to cancel, x cube. Fine. So now f of y given x is equal to this f of xy is equal to 2xy, and this is x cube only, so this is 1 cancel, so this is 2 by x square into y. Okay, so now I have to find the expectation of y given x is equal to we can say 1.5 is equal to 3 by 2. So this is integration y f of y given x is equal to 3 by 2 and dy. Okay, because the expectation of x is equal to x into f of x dx integration, and here the function is y given x, so we have multiplying this and f of y given x, and the integration sign is with respect to y, and the limit of y is equal to 0 to x, and for given that x is equal to 3 by 2, so 0 to 3 by 2, and we have to put a value of x square here also, So 2 by 3 by 2 whole square into y square dy. Okay, 1y is this, and 1y is coming from here, and 1y coming from here, so this is y square. Now, so 2 3 by 2 whole square, and this is y cube by 3, so this is 1 by 3 and y cube. Okay, and 0, so 3 by 2. Now, so this 2, sorry, this is 3, this is 3, so this is if I am putting 2 by 2 by 3 whole square, and this is 2 by 3, so 2 by 3 whole cube, and 1 by 3 is here, so 3 to this cancel. Okay, so this is 4 by 9. Okay, so expectation is 4 by 9. You can write, and you can change in decimal form also. Now the question number 65. Okay, 2 fair coins are tossed independently, and x is a random variable that takes the value 1 if the both are heads or 0 otherwise. So x can take value 1 and 0. This takes 1 when there is a value if both are head. Okay, so this is head head, and this is head tail tail head and tail tail, and y takes the value 1 0 when if at least one of tosses is head. So this is 1 head and 2 head also, and this is tail tail. Now the probability of x with 1 is 1 by 4, and this is 3 by 4, and this is 3 by 4, and this is 1 by 4. Okay, so expectation of x is equal to 1 into 1 by 4, which is equal to 1 by 4, and plus 0 into 3 by 4, so plus 0 into 3 by 4, which is equal to 1 by 4 only. And similarly, expectation of y is equal to 1 into 3 by 4 plus 0 into 1 by 4, which is equal to 3 by 4 only. Okay, now expectation of xy, which is the common, you can say that key, this is the common factor in x and the y also. Okay, so the expectation of x into y, so this is the common one is the common thing is this means the head and head only, so 1 by 4 only. The expectation is 1 into 1 by 4. Okay, the intersection thing, so means x intersection y is equal to head head only, and this is probability is this is 1 by 4, so 1 into 1 by 4, which is equal to 1 by 4. So covariance is equal to expectation of xy minus expectation of x into expectation of y. Okay, so expectation of xy, this is 1 by 4 minus the expectation of x is equal to this 1 by 4 multiplication with this 3 by 4, so this is 1 by 4 minus 3 by 16, so this is 1 by 16 only, and this value is equal to 0.0625. Okay, so this is the answer. So this is the question number 5. Okay, so this is all about the solution of this paper of 2024, and if you like the video, then it's well, and if you want me to cover all the topics, or if you want topics from the statistics, please let me know in the comment section, and I'll upload the question from the 2025 paper. I've seen that the lots of question from the statistics background is there in the 2025 paper, and basically I am a PhD scholar in statistics, and I have cleared this mathematical science JRF, and the GATE statistics, and the GATE data science also. So if you want more videos on different topics from the statistics, you can let me know. Okay, thank you so much.